Hello, my name is Shen Kishore from Artificial Intelligence and Data Science Department, studying in Janssen Institute of Technology, first year. Let us now discuss the case study on a topic: application of mathematics in neuroscience. Mathematical neuroscience. Mathematical neuroscience is an interdisciplinary field that aims at modeling neural processes using mathematics. It has both practical and theoretical application in neurobiology. Mathematics in neuroscience. It may be more useful to distinguish between computational, theoretical, and mathematical neuroscience. Computational neuroscience aims to be quantitative and often involves building detailed biophysical model of neurons and networks to study specific neural phenomena. In this field, mathematics is most often used hand in hand with computational tools to numerically explore model behavior. In my study, an analysis is obtained using the quantitative framework and the possible role of acrosite in the contextual memory retrieval. A possible role of acrosites in contextual memory retrieval, an analysis obtained using a quantitative framework. The hippocampus is central to our understanding of memory formation and retrieval. Its CA1 region is known as encoding conceptual memory. Here, using a conceptual approach which embeds existing physiological data, a particular role of acrosites in contextual memory retrieval. Using the very framework, we further studied astrocytic functions in the modulation of neural firing under pathological condition. During astrocytic induction of epileptiform discharge in CA1 pyramidal neurons. Thus, a quantitative framework that would aid understanding of the Schaffer collateral CA1 tripartite synapse in health and disease, and thus it appears that interaction or signaling between neurons and astrocytes plays a role in information processing and memory retrieval. Materials and methods. The complete network comprises of three major components: a CA3 pyramidal neuron, 4 CA1 pyramidal neuron, and an acrosite in the stratum oriens. A CA3 pyramidal neuron is computationally described as Traub's branching dendrite model of the CA3 pyramidal neuron comprising of 21 compartments, 2 spines, to yield a 23 compartment CA1 pyramidal neuron model. Axon and spine compartment were added to from CA1 synapses in the SO at the basal dendrites. The dendritic spine model is modified to include synaptic NMDARs and ENMDARs. The astrocyte model accounts for glitotransmitter release and acrosite dependent SICs through the activation of NR2B containing receptor on the CA1 neuron. G is equal to G max divided by 1 plus exponential of minus V axon minus V proton divided by Kp. Overview of the model architecture. The SIS evoked by the acrosite through the ENMDARs are ISIC, which is equal to GNR2B dot H into Vs. dH by dt is equal to sigma by R1 minus H by R2. The above relation is regulated by acrocytic Ca2 plus by psi by sigma, which has a value of 0.4. Whenever acrocytic Ca plus 2 goes above 200 nanometer, it will be set to 0. The time constant tau 1 and tau 2 govern the time rise and the delay time of the ENMDAR currents. The acrocytes release glucomate and the glucomate secretes vesically utilizing Ca2 plus dependent exocytosis as soon as astrocytic Ca2 plus concentration exceeds the threshold Ca2 plus concentration for triggering secretion. Computer simulation. The network model invoked a total of 1247 ordinary differential equations, which were solved using a quasi-constant step-sized backward difference numerical solver implemented by MATLAB. The system of ordinary differential equation was solved for a duration of 50 seconds, which took approximately 8 hours to compute. Epileptiform simulations. NMDARs are known to play a role in the initiation and progression of the epileptiform discharge. To study the possible effects of glucometric glitotransmission on the ENMDARs, we stimulated the acrocytic dependent pathway after doubling the ENMDAR conductance in the Ca1 neutron. This computational alteration emulates a biological condition of the increased presence of plasmalemma ENMDARs and or flux through an unaltered number of channels. The simulation data suggests that the presence of acrocytic lacking transmission does not affect the firing of Ca1 neutron overexpressing ENMDARs upon their simulation by the Ca3 neuron. Thank you.